Flack math! Give me some math and I'll give you some flack. Flack math!
Number one, is this a scenario where the two distances equal to each other, or the two distances add up to a number, or that one of them is a certain amount after the other? And you might not be able to know until you draw a picture. Anyone know yet? All right, well, let's draw a picture. 300 miles apart at 3 p.m. So let's see, here's one, bicyclist 1, bicyclist 2, 300 miles apart. Okay, so they're 300 miles apart and they met at 9 p.m. So one was traveling at 20 miles per hour. So basically we've got these meeting. So what equation is that? Yes, okay.
D1 plus D2 equals 300.
All right. Okay, so replace the D's with R's and T's. So R1T1 plus R2T2 equals 300. Now we need to figure out if we know any R's and T's. So at 3 p.m. they were headed toward each other. At 9 p.m. they met at 9 p.m. So that tells us that their times are both the same and they both equal 6, right? So that makes it nice. They give us the time, so we know they're both the same. So now we have 2 out of the 4, 20 miles per hour faster than the other. Okay, so let's see. R1 is R2 plus 20. Does that make sense? It doesn't matter which one's R1 or R2. We'll get the same thing either way. Okay, so now we've got something to plug in for R1, and we got something to plug in for both T1 and T2. So R1 is R2 plus 20. T1 is 6. R2 is R2. T2 is also 6. Okay, so this was just me translating it left to right, or just substituting left to right. Now you can leave it like this if you want. I'll distribute backwards here, even though it makes me uncomfortable, that's fine. 6R2 plus 120 equals, or plus another 6R2 equals 300. So far, so good. Now I'm just simplifying the equation and solving it. So 12R2, combine like terms, get rid of 120, equals 24, what is that? 300 minus, so that's 180. Okay, divide by 12, I think that's 5. No. What is it? So, yeah, 15, right? Okay. So rate 2. So what does it ask for? What was the speed of each bike list? So R2 was 15 miles per hour. So what's R1? How do you figure that out?
Divide 20. Don't use subtract 20.
R1 is add 20 to R2. So make sure you keep that straight. Best way to do that is to show as much work as possible. Okay? All right, so that's number 1. You guys feel like you can do that? And most likely it's going to be the same scenario on the test. You're going to have 2 distances adding up to each other. Okay, and I think that's the hardest part of these problems, is trying to figure out which scenario it is. And we kind of just did that for you. All right, unless there's questions, I'm going to move on to number 2. All right, sum of two numbers is 30 and their difference is 10. What are the two numbers? All right, I love these translation problems because it takes these word problems in English and it translates it into a language that I understand. I understand English, don't get me wrong, but I know how to do math a lot better in math language and not English, okay? So the sum of two numbers is 30. How do you say the sum of two numbers is 30?
Like x plus n equals 30.
Yeah, well, let's just use x and y. Okay, and how do you say the difference is 10? The difference of those same two numbers is 10. How do you say that, Oken?
X minus y.
Yeah, x minus y equals 10. All right, now, those of you who have done plenty of these problems, what do you see right away that would be nice, Oken?
Can you, I forget what it's, is it factoring? Or not factoring, but it's where you like put the 10 over and then you put equals 0. Is that what you do?
Yeah, if you were solving by factoring like a quadratic equation, but this is a system of equations. So remember, there's three ways to solve these. One way is substitution, another way is elimination, and the third way is graphing. Okay, so out of those three, which one looks like the most enticing? Substitution or elimination? What'd you say?
Elimination.
Yeah, because what happens when you add these together?
Cancel each other out.
Yeah, these guys cancel. And you're left with 2x equals 40, x equals 20. So if x equals 20, y has to be 10. Because 20 plus 10 is 30, 20 minus 10 is 10. Okay? Now you probably could have spent less time trying to figure out for yourself what these two numbers are, right? Well, what two numbers add to get 30 but subtract to get 10? Well, you probably could have figured it out faster than using one of these methods, okay? But this is great. If you know how to do that, show your work so you get plenty of partial credit just in case for some reason you get this wrong. You show your work. You show me that you know one of these three methods. That's fine. Okay, number 3. Deborah rolls 2 fair dice. What is the probability that the sum of the numbers is rolled is 7? Okay, so the probability of the sum of 7. Remember, probability is the number of favored outcomes out of total number of outcomes. Well, this is something you should remember. How many total outcomes rolling 2 dice? How many total outcomes are there for rolling 2 dice? Do you remember? Rayona?
36.
36. So it's like number of favored is what we call it, what you're looking for over number total. Well, we know that 36 is the total. Now we have to figure out what numbers add to 7. Well, 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. Okay, that's a lot. But how many is that? It's just 6. Reduce 1 6 is your probability. Does it make sense? Yeah,
7 is the most probable number to roll.
that's right. That makes sense because this is the only one where you've got 6 different combinations out of 36. Now, if I said sum of 8, you would have 2 and 6, 3 and 5, 4 and 4, and then 5 and 3, and then 6 and 2. So you have 5. You have close, but not quite as many as 7. Does that make sense? 7 is the most probable number to roll. All right, number 4. Wendy had $10, $10.60 in dimes and quarters. If she had a total of 94 dimes and quarters, How many of each type of coin did she have? All right, it's one of these problems. Okay, let's see if we can translate this sentence into a system of equations. So how do you say $10.60 in dimes and quarters? Any guesses? How do you say $10.60 in dimes and quarters? Elkin?
Do you do like D plus Q equals 1,060?
Okay, so if you count your dimes and your quarters, just the coins, is that going to tell you how much money you have? So if you have 3 dimes.
94 equals 94.
Yeah, so that equals 94. So the number of dimes and quarters equals 94. Oh, thank you. Sorry to interrupt. That's all right. We're going to go to Harry Potter world after this.
Yeah.
So we need my robe. Yes. So do you see how that when you do a money equation, you don't just count the number of coins in your pocket. What do you have to do with those coins? What if you had 7 dimes and 8 quarters? How much money is that?
$2.70.
Oh, how'd you do that so quickly? So what you did is you multiplied 7 times 10 to get 70 cents, and 8 quarters, 8 times 25 is 200. So you have to multiply, you have to multiply by their value. That's a value equation. So if I did that, I do 7D plus, or not 7D, but 10D plus 25Q equals, now since we're in cents, we're going to go 1,060. Okay, does that make sense? You see why that's, now, but then your number of dimes and quarters is, what is it? 94. Okay, so you guys have to be able to know the difference, how to write a quantity equation and how to write a quality or a value equation. Okay, so every time you come up with an equation, make sure you test it. Okay, well, let's say we had 5 dimes and 3 quarters. Well, how do you determine the value? I go 5 plus 3 is 80 cents or 8 cents. No, that's not. That's not what it equals. Eliana, would you mind closing that door? All right, so now we're back to a system of equations. We have, remember, 3 ways to solve this, and really just 2 because we don't want to solve this by graphing. So would you want to do elimination or substitution? What looks more enticing? Elimination or substitution? I feel like you're thinking substitution. So elimination is nice when you have opposites already lined up, or you can get, I mean, we could multiply this bottom equation by -10, but we definitely don't want to multiply by -25. That would make this number crazy and big. So let's get one of these variables by itself. They're practically almost there. So let's get this D by itself. Sound good? This is just D equals 94 minus Q. So now we have something to substitute in for D. So there's my new wrapper name for D. So 10D plus 25Q equals 1060. Okay, so far so good. That's substitution. So let's do that. 940, I'm just distributing, minus 10Q plus 25Q equals 1060. Get rid of 940, and at the same time, I'm going to combine these like terms over here. What's a negative 10Q combined with the 25Q? Right, 15Q, subtract the 940, I get 120. So Q equals 8. All right, so 8 quarters. So how many dimes? Well, there's got to be a lot, right? There's only 8 quarters and there's 94 coins. So what is that, 86? So let's just make sure that adds up to $10.60. Well, 8 quarters is $2, right? So what's $2 plus $8.60? $10.60. It works. Okay, again, this would have taken a little bit longer, but you could have, theoretically, you could have figured out your combination by just using trial and error. There's only 94 possibilities, right? But you can use your common sense to figure out which one it's going to be. If you split it in half and said 47 of each, 47 dimes, 47 quarters, well, 47 quarters, whoa, that's way more than $10. So your brain says, okay, you got to have a lot less quarters. More dimes, less quarters, because you got to lower that value down to $10.60. Okay? So you could have figured it out. You don't have to do it this way. But again, use the math you've been taught and you'll get credit for it, even if you get it wrong. Okay? All right, moving on to number 5. Number 5, 40% of the voters chose Shane. If 540 voters chose the other candidates, how many voters were there? Okay, so I'm going to just translate this and see what happens. Sometimes it works out, sometimes it doesn't. So 40% of the voters. How do you say 40% of? How do you say 40% in math? What?
40 over 100.
You could say 40%, 40 over 100 if you're a fraction type of person and you like fractions. That's great. The other option is decimals. How do you say 40% is a decimal? Iona?
Just 0.40.
Yep. So 0.40 or just 0.4. And how do you say of? Times. And voters, we don't know. So 40% of voters chose is my verb. And I'm going to say Shane. Okay, so that doesn't really help me right away, but let's keep reading. If 500 voters chose the other guy or the other candidates, how many voters were there? So now we have to turn on our thinking caps and figure out, well, if 40% chose Shane, what percent chose the other guys? 60%. So I could scratch this idea and say 60% of the voters chose the other, but we know that the other 540. Okay, so 540 voters chose the other. Okay, so 60% of the voters chose the other. Okay. Because it tells us what the other guys were. 540. That's how many votes the other candidates got. Okay, so now we just divide by 0.6. And we get 900. So 900 voters total. Okay, you can run it through the scenario. 40% of 900 is 360. 60% or 540 chose the other candidate. So 360 plus 540 is 900. That makes sense. All right. Use the difference of two squares theorem to find all the solutions. You don't have to use the difference of two squares theorem, but you can if you want. A squared equals 49. So that's when you can subtract 49 from both sides, and you get a squared minus 49 equals 0. Okay? So how do you factor a difference of two squares? Remember doing that? So that's still this. A square root of the first, square root of the second. Adding one, subtracting the other. So what a's will make this 0? What a will make this 0? -7. What a will make this 0? +7. So there's your two answers. Okay. Now you could have just said, well, just square root both sides. Why are you doing the difference of two squares there? Well, that's what the directions say. But I could have done this. Said a equals positive or -7. So make sure you give me two answers. So you need a +7 and a -7. Okay. So can you do B? B is b squared equals 18. Well, you could do the difference of two squares theorem, or you could just take the square root of both sides. I'm going to take the square root of both sides, and I get b equals positive or negative square root of 18. Can you take the square root of 18? No, but what do you always have to ask?
I hate that.
What perfect square goes, is there a perfect square that goes into 18? Yeah, what is it?
9.
Okay, so 9 goes into it. You take 9 out, it becomes a 3, so you're left with 3 radical 2. But if you can't do that in your head, just do a little factor here. Square root of 9 times the square root of 2. Okay, so then you end up with 3 times the square root of 2. All right, now, half of you will reverse this. And you'll end up with like 2 radical 3 instead of 3 radical 2. So you got to keep this straight. The radical square root of 18 is just the square root of 9 times the square root of 2. Square root of 9 is 3. That was the whole point of doing this, is you're trying to figure out what perfect square you can actually take the square root of. There is a perfect square hiding inside of 18. Pull it out, and it becomes its true identity. It's not a square root of 9. It's 3. Okay, and you're left with square root of 2, because that's the other factor that you can't take the square root of. So that needs to stay under the radical. All right, can you do C in your head? What's Z equal to? Elkin?
I put positive or negative radical 13.
That's it. And there's no square hiding inside of 13, right? That's a prime number. Even if it wasn't a prime number, there still has to be a factor that's a square. So z squared equals 13. So z, don't forget the positive or negative, and you can just write it like that, so you don't have to write two answers. You can just write positive or negative square root of 13. That's it for C. Okay? So probably the most difficult one would have been B, but just make sure that's reduced. If you just tell me B equals positive or negative square root of 18, like Elkin did, then you would have still got half credit, okay? Because you did half of it right, but just like fractions, if you don't reduce your fractions in your answer, you get half off, okay? So if you don't reduce your radicals, then you're going to get half off. All right, how's this feel so far? Doable? Okay. All right, let's move on. We've got 4 more to do today, and then we'll do the rest on Thursday. I don't think this board was used a lot while I was gone.
No, it had the same thing on it, like for 3 days.
Yeah. All right, number 7, given our 5 functions. So we have to match these with what you think they are. Okay, so you remember when we talked about this, you don't need to know how to graph it. You just need to know how to recognize what kind of graph it is. Okay? So, what's the best way to do it? Let's just go down to the graphs. Look at A. What kind of graph is that? It's like a parabola is what it's called. It's a parabola, but what kind of functions go with parabolas? Or can you tell me what you think it is?
Is it x2 plus 1?
Yeah, so this is a square function. So this is, whenever you see a parabola, then that you're going to look for an x squared or something squared, okay? Look for an x squared. Well, there's only one function with an x squared, and that's b of x. So b of x equals x squared plus 1, okay? All right, now b, what are you looking for there? So you're going to look for, what kind of function is that? Cubic function. So you're looking for an x cubed. Now this is actually upside down because normally they look like this. Okay, but when it's flipped upside down, that means you're going to have a negative sign in front of it. Okay? So that's what that negative does on these graphs. It just flips it upside down. Think about a linear equation. A positive slope goes up like this, right? But a negative slope, if it's negative, it's flipped upside down. So it kind of, so you take this piece of paper and you flip it upside down, and now it looks like this. Okay? So look for a negative x cubed. And that looks like it's right there. C of x. C of x equals negative x cubed. Okay, good. All right, what about C? Well, that's just a line. Lines have a degree of 1 or a dimension of 1. So which equation is that?
X plus 2.
Yeah, it's just that first one. A of x equals x plus 2. So you're just looking for just an x. Or, you know what I mean by x. It could be y, or it could be like L or Q, whatever variable it is. But you're no exponent. So you're no exponent. Or really, the exponent is 1, right? Okay. All right, well, what about the next one? What is D? What kind of function is that? Absolute value. Okay, so you're going to look for absolute value of x, or some absolute value of something. So that's D of x equals absolute value of x plus 3. And if there is a negative sign in front of it, not inside of it, because inside of it, it would still look like that, because it would still be positive. But in front of it, it would just be flipped over, right? Okay, and then the last one is this little rocket shooting off. This is, you're looking for a square root. You're looking for a square root of x, or square root of something. Okay, so that is e of x equals the square root of x. Now, if it was not a rocket shooting off, but it was a rocket going down like that, then that would be a negative square root of x. Okay? Yes, sir.
What would the cube root of x look like?
Cube root of x. Well, I mean, we could graph it if you'd like to do that, but it would be double layered. Cube root of x actually looks like this. Okay, so it's kind of like the square root of x, but then it has a counterpart and flip the other way. Okay, that's what a cubed root of x would look like. It kind of makes sense because it's the inverse of x cubed. X cubed is when it looks like this. So when you reverse the x and y, it's going to look like that. Okay? Good question. All right, that's number 7. Should we move on to number 8 and 9 and 10?
Mr. Flack.
Yeah.
Okay, so I mean we finished homework, but what's it called? Can I just write it in like order as like C, A, B, D, E?
Yep.
Instead of writing all the equations.
Yeah, however you want to do it is fine.
Okay.
You can, yeah, I'll figure it out. Okay, number 8. Number 8, simplify. All right, copy dot flop. So I'm going to do that first, and then I'm going to factor 3x squared plus 3x over x squared plus 8x plus 7 dot x squared plus 2x minus 35 all over 3x squared minus 75. Does everyone understand that first step? I just turned that into a multiplication problem. Division problems are just multiplication problems upside down. All right? So, first step, factor. First step to factoring. How do you factor 3x squared plus 3x? What do you look for first? If you forget,
What can
look
go
up
into
here. Yeah, what goes into both 3x squared and 3x? Well, a 3 does, obviously, but also an x. You take an x out, 3 and an x out of it, you're left with an x, and then you're left with, what are you left with here when you take a 3x out of 3x? Not 0, but 1, that's right. Okay, don't make that mistake. That's a very common mistake. Remember, you're still just dividing it out. When you divide something by itself, you don't get 0, you get 1. They would cancel if they were on top of each other. But when you cancel a division problem, it really cancels the 1. And most of the time, that 1 just disappears because there's something else there. But when there's nothing else there, you have to put that 1. Okay? All right. So we're done with that. Now, how do you factor this? X squared plus 8x plus 7. Nathan? Okay, yeah, is that a difference of 2? No, it's 3 terms, so it's not a difference of 2 squares, and it's not even a difference. There's no subtraction in there anywhere. So the next step, look for a factorable trinomial. Remember that magic question? Yeah, what multiplies to get 7, and then adds to get 8? Well, there's only one thing that multiplies to get 7.
Oh, I was.
Okay, so what is it? Yeah, so 7 and 1, and they're both positive. Positive 7 times positive 1 is positive 7, but positive 7 plus positive 1, when you FOIL it out, you get x squared plus 1x plus 7x. 1x and 7x combined to 8x. Okay, good. All right. Go here. Also, it's another factorable trinomial. I saw right away there's nothing you can pull out of all 3 of those. It's not a difference of 2 squares. It's not 2 of anything. It's 3. The last possibility is that it's a trinomial that's factorable. Can you factor that? What is it?
I got x plus 7 and then x minus 5.
Perfect. Plus 7 minus 5. 7 times negative 5 is negative 35. Well, how do you know which one's positive? One of them has to be positive and one of them has to be negative, right? That's how you end up with a negative 35. Well, how do you know which one is positive? Yeah.
Well, the 2x is positive,
Yeah.
so basically it's gonna be 7 and 5. So
Yep. So in this case, the
Negative
bigger
five.
one has to be positive because you have to end up with a positive 2x, not a negative. If it was a negative 2x minus 35, that's also factorable, but it'd be x minus 7, x plus 5. Okay, whatever sign this is got to be the bigger number. All right. Okay, what about down here? 3x squared minus 20 or 75. First step is do what? Take a 3 out. Always look for a GCF first. But look what happens. What are you left with, Nathan? When you take a 3 out, what are you left with?
X squared minus 5.
Which is what?
It's
Yep.
squared.
It's a difference of 2 squares. We finally got our difference of 2 squares. So how do you factor that?
can you do x plus 5 and x minus 5?
X plus 5, x minus 5. Good. And I'm going to even cancel that out. Or not cancel it out, but I don't want to be confused by it anymore. This is my new denominator. This is my new numerator. So now I take out my red pen and I have some fun. What can cancel?
Like everything.
Like almost everything. That's right. What cancels?
X plus 7.
X plus 7s. Yep.
X minus 5.
X minus 5s.
3's,
Plus
right?
1s.
The 3's. Yep. What else? X plus 1s, you said? Okay. So it looks like we're just stuck with one thing on the top and one thing on the bottom. What are we stuck with on the top?
X.
X. What are we stuck with on the bottom?
X plus 5.
That was beautiful. I love it when that happens. And the one on the test will probably be very similar. It usually is. You feel good about that? Okay. Go slow. If you find you're not canceling things, it might be that you forgot to copy that flop or you factored wrong or something. But you will cancel some things. There will be some satisfaction. Okay, so we want to graph this on a number line. So first step to graphing is to solve for x. Okay? So how do you solve for x? We got negative x plus 5 is less than or equal to 6. How do you solve for x? Yep, so get rid of 5. So negative x is less than or equal to 1.
But don't you flip it?
If you multiply or divide by a negative number. If you just
I
subtract
thought you already did that.
No, but yes, if I want to get this x, a positive x, I either multiply by negative 1 or divide by negative 1, right? If you negate, that's the same thing as multiplying or dividing by a negative number, which means in an inequality, you have to flip the stinking symbol. So this is that one wrench in the plan that makes it different from solving an equation. And actually, it's really not different from solving an equation. You could flip an equal sign, and what happens when you flip an equal sign? Nothing, right? So you could apply the same rule to solving equations. It'd be silly, but that way you're consistent with the rule. Anytime you multiply or divide by a negative number or negate a side, you have to flip that symbol. So this positive x becomes greater than or equal to negative 1. Okay. All right, well, I need a negative 1 on my graph. I'm going to put a couple more points on there. But I also know that the domain is real numbers. What does that mean? What does domain real numbers mean? How do I graph it?
Just everything.
Yeah, everything. Just shade it. Okay, if it was integers, then I'd probably just graph negative 1, 0, put a dot on each one. but this is real numbers. So I'm going to fill it in, right? Because this means fill it in, and then shade to the right. So if you get this wrong, you're probably going to shave to the left. Not shave. You're going to shade to the left because you forgot to flip that symbol. All right. So remember, if you're multiplying and dividing by a negative number or just changing a negative to a positive, then you have to flip that symbol. Can you guys remember that? All right. Number 10. We should do just number 10 and 11 since they're both the same kind of problem here. Number 10, x squared plus 13x plus 42 equals 0. Why'd I do that? That's not the problem. Because the first step to solving by factoring is to get everything on one side equal to 0. Okay? And make sure that x squared is positive. So put it at whatever, put it on the side where x squared is going to be positive. Well, x squared is positive on the left, so put everything on the left side and then 0 on the other. Okay? So do you see what I did? I brought that negative 42 over and it becomes a positive 42. Now we just factor. What's the magic question? Yep. Okay, what two numbers? What's our secret combination, Nathan? 6 and 7 or 7 and 6. Okay? So you're almost done, but now you have to solve this equation. So the last step is to set each factor to 0 and solve. You could probably do this in your head. What will make this factor? Because remember, when you multiply two numbers to get 0, one of them has to be 0. So what x will make this parenthesis 0? Alka knows. Who else knows? Eliana? Yep. So a negative 6 would make this 0. It would make this positive 1, but who cares? Because 0 times anything is 0. And then what would make this 0? What x? Negative 7. Okay? Questions? Yeah.
Couldn't you also do it as x minus 6 and an x minus 7?
Well, that would give you a positive 42, but it would give you a negative 13x. Okay? All right. So one more. X squared plus 16x. I'm going to bring that 64 over already. Equals 0. And then factor, what's my number combination?
2 8s, right?
Just 2 8s, right? Plus 8, plus 8. So what's your only answer?
X equals.
Yeah, x equals negative 8. Now in algebra 2, we're going to realize you have to say negative 8 with a multiplicity of 2. Because technically you get two answers, negative 8 and also another negative 8, right? Well, we don't say that. The answer is only negative 8, but we say it has a multiplicity of 2. But don't worry about that now. We're going to do that next year. All right, you guys good?
Black man.